Welcome to the fourth of 7 videos covering quadratic theory for higher maths. This video is going to be hopefully a short one covering sketching quadratics. So, learning intention. I want you to be able to sketch a quadratic from a given equation. This topic in its own right is quite sizable, but at this stage, as in this, early in the course, I can only give you chunks of what we want to cover for this because either the skills you need to use it, and in our context, you haven't covered or won't cover for a while. So obviously, this is an introduction, but is by no means the end of this topic. Is actually just an intro in preparation. Some of this will be covered later within the quadratic theory, and some of it will be covered much further down the line within polynomials, differentiation, and so on. So be prepared to start this topic and it be a kind of continuing theme through different phases of the higher maths course. So sketching a quadratic. When sketching a quadratic at higher, the same method applies as what you would have been shown at National 5. However, it's important here that it's likely not all the info that a sketch at National 5 would have required will be required here. National 5 was just, can you sketch this quadratic? There was really no context to why they were asking you to do that. At higher, there will now be context to that. So therefore, some of the information, some of the features of a quadratic might not be necessary in your sketch, as they will provide no relevant help to what you're actually being asked to use it for. So again, the skill here at higher will be putting in the information that's necessary and is therefore relevant. So again, what to include will be dependent on what's been asked, depending on the context. So at the moment, I can't tell you these contexts because some of them won't make sense. But as I come to them and cover them within the higher course, obviously I'll allude to the sketching and I'll make mention of what you need to include. So the following are the 5 main items that will need to be considered for the sketch, some of which is from National 5, some is kind of tweaked to kind of fit the higher course. So the general shape of the quadratic. If the sketch is relevant and part of what you're doing, this is important, right? So it must be included. If you get it wrong and draw a negative, what was it, a minimum turning point when it should be a max, that's going to be quite a big fail in terms of your sketch and whatever uses kind of going to be providing. Could be ruined by the fact that you draw it the wrong way round. So that will be important, and I can guarantee will need to be part of any sketch. The roots of the quadratic. In general, most sketches at higher will need the roots included. Okay. Again, that isn't categorically the case because there are some scenarios where you maybe don't, but I'd be very surprised if you don't need to include the roots when you do. The y-intercept coordinate. This is less likely to be needed. Again, it might be depending on the context, but as a general rule of thumb, very much less likely to be needed. The turning point coordinate, this may or may not be included. It's very context relevant, as in what the question is asking you. So sometimes it's needed, sometimes it's not. So it's not as important as the general shape, probably less likely than the roots, but still very much a consideration depending on the question. Last but not least, there will possibly be other relevant coordinates that you need to include in any sketch. Again, this will be dependent on the type of question you get asked later down the line. Sketching, the graph of a derivative, you may need to include another coordinate that's given. So there's an example, won't mean a lot to you. You'll be, what's a derivative? But further down the course, this video makes sense when you watch back having covered that topic. So everything's context dependent, but general shape, roots are likely to be included no matter what the context is. Quick example, I'm not going to give you any context-based one, just a quick example recapping how you sketch. So if I ask you to sketch the graph of y equals x squared plus 2x minus 15, at your exam, the context is likely to tell you what to include and what not to. If the question doesn't, and it is just a sketch one, unlikely, but in the scenario it's what's been asked, you need to include everything that's possible. So you need to include a turning point need to include the turning point. You need to include the y-intercept, and you need to include roots if there are indeed roots. Beyond that, you haven't been given any other points, so that's all. And the general shape. They're the 4 things that you need to include in this type of question. So find the roots. Best method: factorize if it can be factorized. X minus 3, x plus 5 can, so that gives an x coordinate of 3 and x coordinate minus 5. So 2 roots occur at minus 5 and 3. Second step, find the turning point. It's up to you. You can either find the turning point by completing the square, or remember that the turning point lies halfway between the roots. the x-coordinates of the root, so it will lie halfway between 3 and minus 5, which is minus 1. So you sub minus 1 back into the y equation, either one, and calculate your y coordinate. Therefore, the turning point is at minus 1, minus 16. Third thing you need to find is the y-intercept. Remember, in standard form, the y-intercept is simply the coefficient at the end, so it is, in this case, minus 15. But if you choose to not do that, you can just find the y-intercept by remembering at the y-intercept, your x-coordinate will always be 0, so you just place x by 0 in your quadratic equation and solve for y. So the y-intercept is at 0, minus 15. We now have all our three main points. We know what type of shape it is because it's a positive x squared, so therefore it's a minimum turning point. So when we draw it in, plot in all the points, marking them, clearly stating them, make sure they're visible so that somebody knows what those points are and what they're marked as, and draw the shape.